Okay. So in the problem of the day here, I asked you to find dy dx if y is equal to this. Okay, dy dx means the derivative or the change in y with respect to the change in x. How fast y is changing as x is changing. The very instantaneous rate of change in y with respect to x. The instantaneous slope. I'm saying the same thing over and over again, but I'm trying to get it to click and make sense to you, okay?
Oh, and since y is 1.
What?
Never mind. The second one.
Okay, so we have been finding the derivative all along, okay? The thing is, all of our equations that have been given to us for us to find the derivative of have all been written explicitly. Okay? And explicitly means they've all been written y equals, or f of x equals. Okay? They're all explicit functions. Well, unfortunately, not every function can be written as an explicit function. Circles, ellipse, crazy shapes that are not functions because they don't pass the vertical line test cannot be written where y is by itself. So you can't write every function as y equals. So but you could still, there's still got to be a way to find the instantaneous slope on the edge of a circle, okay, or the slope of a tangent line somewhere on the circle. So that's what implicit differentiation is going to help us to be able to do. Okay, and like I said, you really have been doing it all along. So when I said find dy dx, you guys went through and you got the derivative, and you could write dy dx equals following all your rules, things like that. Okay? Well, what you did to go from this to this was you differentiated both sides of the equal sign with respect to x, as if x kind of were your variable. Okay? This is simple. These are all x's, so differentiate like you always do. This side is not an x. Okay? But we actually used implicit differentiation without even knowing it. What's the derivative of y?
1.
1. Okay? But what we do then is when we do implicit differentiation, whenever you differentiate using a variable that you're not differentiating with respect to, so if I ask you to do dy dx, you're differentiating with respect to x, you're trying to find how fast y is changing with respect to x. Anytime the variable's not x, you need to just put in dy dx after you differentiate the variable that's not the one we're interested in. Okay? So when we differentiate y, well, the derivative of y would just be 1, but then you have 1 times dy dx. Because we have to put that in there. This is just kind of a procedural thing. We put that in there because we differentiated a different variable other than the x that we normally differentiate with respect to. Yes, Luke?
So, for the examples where it's d over dx, is that only for explicit form?
Well, the thing is, if they ask you, the notation you usually see for d of dx is they give you this. You know, they don't even write an equation. They're just telling you to find the derivative of this with respect to x. They didn't even write an equation. That was just an expression, really, that you were finding the derivative of. Understand the difference here a little bit? Okay? All right? So, for example, let's say I have an equation of a circle. I'll make it a simple circle too. X squared plus y squared equals 16. Okay? If you recall, that is the equation of a circle, and what are some characteristics of that circle?
Oh, I got this.
What do you got?
It centers at the origin.
Nice.
Radius of 4.
Boom. Okay? Centered at the origin with a radius of 4. Okay? That's what this picture would look like if you were to graph it. Okay? Now notice, we really can't write this in terms of y. Yes, we could, but you'd have to have two equations. You'd have to have y equals a positive square root of 16 minus x squared, and y equals a negative square root of 16 minus x squared. We don't want to do that. Okay? I can still find the derivative of this function. And by finding the derivative of this function, I could then in turn find the instantaneous slope along the edge of the circle at any coordinate. Okay? So I'm going to do the derivative of this. I'm going to differentiate both sides with respect to x. Okay? What's the derivative of x squared with respect to x?
2x.
2x. What's the derivative of y squared? 2y, but because we differentiated a variable that was not x, we just put times dy dx. So it'd be plus 2y, and then because we differentiated with a variable that was not x, we just put in that dy dx right there. Right, multiply it right by the derivative of the variable that's not x. And what's the derivative of 16? 0. Okay? So 2x plus 2y times dy dx equals 0. You will see some text and some teachers, instead of put dy dx, you recall we've also used this to represent the derivative of y prime. Sometimes you'll see teachers or textbooks write 2y times y prime. And some of you might say, yeah, that looks faster. Yeah, I agree. Okay? Here's the problem with it. Sometimes you forget that's your y prime, that's your dy dx, and you think that's y to the first power, and then all of a sudden this becomes 2y squared, and you've really got it all screwed up. Okay? So I don't think that's a great idea, but I will tell you, you could see that notation. Okay? Now, let's get dy dx by itself, because that's what we're trying to do. We're trying to find the derivative of y with respect to x, so we want to know what this equals. If we're trying to get dy dx by itself, I would subtract 2x from both sides. So 2y dy dx equals negative 2x. Then what? Divide by 2y. So dy dx equals negative 2x divided by 2y, which would simplify to
Negative x over y.
negative x over y. So this is the derivative of y with respect to x. This will give us the instantaneous rate of change of any coordinate along the outside of that circle. Okay, and I'll show you how that works. We'll pick an example here. Okay, and we'll find the slope at that given point. So negative x over y is how we would find the instantaneous rate of change along that circle somewhere. Okay? I'm going to draw that circle, or try to. This is usually hard to draw and make this look pretty, but I'll
Beautiful.
Okay? Alright. Alright, so let's say we wanted to find the slope back here at negative 3, comma, well, I can tell you what that would be, because if this is 4, let's see, negative 3 squared plus y squared, that's equal 4 squared, 16 minus 9 is 7, so y is the square root of 7. So, negative 3, comma, negative square root of 7. This is the coordinate right here on the circle.
So it would be 3 over the square root of 7? Oh. It's not bad.
Negative.
Well, oh, because
Right?
it's negative 7. Never mind, yeah.
Right? If I want to know the slope of the tangent line at that coordinate, anytime you want to find the slope of a tangent line, all you do is you take that coordinate and plug it into the derivative. A lot of times, though, our derivative has always been just in terms of x. So all you needed was the x value to plug into the derivative. Well, now, our derivative is in terms of x and y, so you would need to know both the x and the y coordinate in order to find the slope of that tangent line right here. The slope of the tangent line, remember, dy dx is equal to negative x over y, right?
Yeah.
So in this case, the opposite of x would be 3 over negative root 7. So in this case, the slope of this tangent line would be a negative 3 over square root 7. This would be the slope of the tangent line of the circle at that coordinate. All I had to do was take the coordinate and substitute it into my derivative. So really the only difference is now you have both an x and a y to plug numbers into to find your instantaneous rate of change, or your slope. And you could pick any point along here and find the slope of the tangent line. If you pick this point right here, 4, 0, 4, 0, what's it mean when there's a 0 in denominator? Undefined. If you have a line whose slope is undefined, what kind of line is it?
Vertical.
A vertical line. What would be the equation of the tangent line right there?
Does not exist.
Equation of the tangent line, sure it does.
Oh,
Oh,
y
X equals 4 because it was a vertical line, and we know vertical lines are always x equals some number, so the tangent line right here would simply be x equals 4. Okay? Those should be easy, the ones here, here, and here. What would be the tangent line right here?
y equals 4.
Y equals 4.
X equals
X equals negative 4, and so on. Okay? What's the slope of the tangent line right here? 0, right? Because it'd be a horizontal line. Okay? So that's implicit differentiation. Whenever you have a y in the equation and you do the derivative with respect to that, or with respect to x, you got to add the dy dx part. Okay? Go to page 144. This looks like a fun one.
what year?
We're going to differentiate this function.
Okay.
You can see the graph of it. It's kind of a sideways figure 8 or infinity type symbol. Kind of a funky graph. That's just to help you visually understand what we're doing here. Okay. Alright, so if we want to find the derivative of this, thoughts?
First, you'd want to chain rule.
Well, are we fine leaving it like it is and just going straight to the chain rule? I think that's fine. Okay. You could FOIL this if you wanted to and distribute the 3, but I don't know if that's going to be any less work in the end. Okay. So chain rule.
6
So 6. What happens in the parentheses?
stays the same.
Stays the same. And now this is raised to the first power. But what do we still need to do?
Multiply by 2x plus 2y.
That is the what? Derivative of what's inside the parentheses. So we need to multiply this by the derivative of what's inside the parentheses. That will be 2x plus 2y dy dx.
Oh, whoops.
Because right there at that moment we did the derivative of a y instead of an x.
And then equals 100.
Nope.
Oh, equals 100 times dy over dx.
Well, what are we going to have to do to differentiate 100xy?
Give 100 to each.
Oh, it's multiplication,
Product
not
rule.
addition.
Product rule. 1 d2 plus 2 d1. I would call the 1 100x and the 2 your y if it were me. Okay? So 1 would be 100x. d2, the derivative of y is what? 1
dx.
dy dx. Or just dy dx. Okay?
That's
Plus 2. What's the derivative of 1? What's the derivative of 100x?
100.
100. Okay? Alright, so there's our first step. Now we got to get dy dx by itself. And you'll notice there's a couple of them. Okay?
Don't you put them all on one side? Or?
Yeah, you're going to probably have to...
I want to 75.
Yeah, I think you will. So, this would be 6x squared plus y squared. If I distribute the 6, right? And then I still got this. 2x plus 2y dy dx.
you
y
distributed
squared?
the 6?
I just distributed the 6. I'm not going too fast.
So wouldn't it
here.
be 6y squared?
Yeah.
Thank you.
Nobody.
6x squared plus 6y squared, sorry. Times 2x plus 2y, dy dx equals 100x
Distributed.
dy dx plus 100y. The right side at least is simplified, but we still got some work to do on the left side. What do you think? What's that? Foil it, yep. 6x squared times 2x would be 12x cubed. 6x squared times 2y dy dx, well, that's not real clean, but it is what it is. 12x squared y dy dx. Plus 6y squared times 2x would be 12xy squared. And then the last would be 12y cubed dy dx. Equals our 100x dy dx plus 100y.
Let's use some parentheses.
This is fun.
Requires you actually to write out a lot of work.
Ooh.
That's
About
John's
notebook
weakness.
today.
That's John's weakness there.
Right? Now, because you're trying to solve for dy dx, I move everything with the dy dx onto one side, I move everything without a dy dx over to the other side.
Well, we could at least divide by 2.
I got it.
It's almost.
Actually, divide by 4.
So this one can stay,
Rattle.
this one can stay,
Should we divide all by 4?
if you want to. This one would move over and it would become negative.
Yeah.
On the other side, you'd have the 100y minus 12x cubed minus 12xy squared.
Interesting.
I'm gonna change that, because then there's less numbers.
Now we'll just factor out the dy dx.
Oh, one sec. Let me look.
Okay. Right? Okay. I'll factor out the dy dx because I'm trying to get dy dx by itself. If you factor out the dy dx, you still got 12x squared y plus 12y cubed minus 100x equals the other side. And then your very last step will simply be to do what?
Divide both sides by...
What's in the parentheses? That quantity?
Yeah.
That's gonna be really nice.
It is.
Oh, lovely.
It is really nice.
Would you just like us to leave it that way, once we move it over?
Yeah, you're not gonna have to do much.
Okay, thanks.
It's
Yeah.
very nice.
Yeah, it would probably be a good idea to divide everything by 4, but. So, I'll need a little help, I'm gonna have to change screens here.
Okay.
Don't worry, it's all in the steel trap.
Alright, what is it then, John?
So we're gonna start off with 100x. Nope, you're not gonna.
Alright, Luke, help me out.
I tried.
Let's see here.
12x squared.
Alright, let's go.
Yeah.
Wait, are we?
The right side,
The right side
I'm
first.
sorry.
Right
Okay,
side
yep,
first.
this
yep.
divided by
Okay.
this.
Oh, I thought we were.
100y minus 12x cubed minus 12xy squared. 12,
Over, go ahead.
12x squared y plus 12y cubed minus 100x.
And then, yes, if you would like to, and if the directions would say to simplify it as far as you possibly can, you would want to divide everything by 4.
That's what I didn't want to say, because I already had it divided out, so.
Oh, gotcha, yep. So divided by 4, that'd be 3, 3, 3. The book did a little bit differently. I don't know if you would have followed that as well, but the book did do it differently. Not a bad way.
Is this like the longest kind of problem we'll have?
What's that?
Is this like the longest kind of problem?
That would definitely be the upper limit of something. Yeah.
For this unit.
Okay.
Just a reminder that you have until noon to get your football playoff apparel order in.
Oh no!
Noon today to get your football apparel order in. Thank you.
All right. Now, if you would have to find the slope of the tangent line at a given point,
That'd be terrible.
actually that is so much better than what we did so far. I mean, just if you had to plug in the point, what point do they ask you to? Don't they give you one?
It's
3-1.
Oh yeah, that wouldn't be terrible at all. I just go straight to my calculator, type in the top with parentheses and 3 in place of the x, 1 in place of the y, then do the bottom, get your 2 answers and go. Not near as bad as what we've done so far, so. But, homework?
How much time do we have on it?
Classes.
Over? I might have.
Come on.
Did you freak out? What? Did you freak out? I was like, I got up and I was like, yes!
Homework, here you go, page 146, 1 through 4, 22, 34, 53, 54.